We all think of Python as this amazing, superpowered calculator, right? It's fantastic for crunching numbers. But what if you wanted it to do actual algebra? So today we're going to dive into a pretty fascinating capability that really takes Python from being just a calculator to a full-on symbolic math powerhouse. Okay, so let's start with something that probably looks pretty familiar. This is the kind of thing you definitely saw in a high school algebra class. Seems simple, right? Totally straightforward, just a few variables. But here's the twist. If you know all the other values, finding A that's easy for a computer. But what happens if D is the thing you don't know? So how in the world do you get a program to actually rearrange the equation itself, to isolate D all by itself on one side? Well, that is a much, much trickier problem. And believe me, this isn't just some theoretical puzzle. This is the exact challenge a developer posted on Stack Overflow way back in 2009. They wanted to build an app that could just dynamically rearrange a formula, depending on what the user needed to solve for. So what's the first tool you'd probably reach for in Python to tackle a math problem? I'm guessing the built-in math module. So let's jump into our first section and find out why that obvious choice, well, it actually falls short here. So what exactly is the math module? Well, think of it as Python's trusty built-in calculator. Its entire universe is numbers, specifically floating point numbers, and it gives us access to all the common math functions we'd expect. And listen, it is fantastic at its job. If you need the square root of 9, or the sine of pi, or the factorial of 5, the math module is absolutely your go-to. It just takes numbers in and it gives numbers back. It's a pure number crunching machine. And this right here, this really gets to the heart of the problem. On the left, you've got numerical calculation. That's the math module's home turf. But on the right, that's our problem. Symbolic manipulation. It's all about working with abstract symbols like A and B. We're not trying to calculate a value, we're trying to rearrange the very structure of the equation. So at the end of the day, the math module just sees A as a placeholder for some number. It doesn't see it as an abstract concept. It has no idea about the rules of algebra it would need to isolate D. Honestly, trying to make it do this is like asking a calculator to write a poem. It is just fundamentally the wrong tool for the job. So if Python's standard tool can't handle it, are we just stuck? No, not at all. This is where the solution gets really cool, and it actually comes from outside the standard library. And the answer, which was provided in that classic Stack Overflow post, is a library called SymPy. SymPy is built for exactly this kind of thing, symbolic mathematics. It basically gives Python the algebraic brain it was missing. And what's amazing is how simple the process is. First, you just define your abstract symbols. You're basically telling SymPy, hey, these letters aren't just placeholders for numbers. Second, you set up the equation. And third, you just ask it to solve for the variable you care about. It's just so intuitive. And just like that, voila! With that one single solve command, SymPy does all the heavy lifting. Multiplying by E, subtracting B, dividing by C, and it gives us the perfectly rearranged formula. This is the exact solution our developer from 2009 was looking for. And that's really the key here, just one. It took just one specialized library to totally transform what Python is capable of. It turns it from a simple number cruncher into a partner that can literally reason about the structure of mathematics itself. But SymPy isn't an island. It's really part of a much bigger story about Python's mathematical power. So for our final section, let's zoom out a bit and see how this fits into the whole ecosystem of tools that are available to you. So while we did have to go outside the standard library for symbolic math with SymPy, Python's own built-in tools are incredibly rich for all sorts of other specialized numerical tasks. In fact, the official docs call them the numeric and mathematical modules. And wow, just look at the range here. The standard library has modules for pretty much everything. You've got decimal for that super high precision financial math, statistics for analyzing data, random for running simulations, and even C math if you need to work with complex numbers. So let's wrap this up. What are the key takeaways? Really, it all comes down to knowing the right tool for the right job. If you're just crunching numbers, the standard math module is perfect. But the moment you need to manipulate equations as abstract ideas, you need a powerhouse like SymPy. And together, they make Python this incredibly versatile platform for almost any mathematical challenge you can throw at it. This just opens up a whole new world of possibilities, doesn't it?
It's not just about solving for D. It's about automating complex derivations, building smarter scientific tools, tackling problems that before were just out of reach for a simple script. So the real question is, knowing that this is possible, what complex problems will you solve now?